In this video, we'll talk about exponential growth from a calculus point of view. But before that, I want to discuss this topic with you. For what function y, so that the derivative of y is equal to k times y? Well, we actually talk about a function with derivative look like that, which is y equals e to the x, right? The derivative of e to the x is e to the x, which is the derivative of y is equal to y itself. Okay, what about ky? Well, then it has to be e to the ky, right? So that when you take a derivative of that, you will have, I'll write it a different way. When you take the derivative of e to the ky, you will have e to the ky. Well, then you have to take the chain rule, so you will have a k in the front. Actually, there's only one type of equation or function that satisfies this equation, the derivative of y is equal to k times y, which is y equals c times e to the kx, where c is a constant, k is also a constant. So if and only if. Now let's look at this example. Find the function that satisfies that dA dx equals 5a. Okay, according to the theorem we just talked about earlier, the only function that satisfies this condition is the function that looks like this, right? So a of x, this function, should be equal to c, which is a constant, times e to the 5x. And this equation, y equals c times e to the kx, is actually equation for the model for the uninhibited population growth. Your output p represent the population and t represent the time. When we don't have factors to inhibit or stimulate the population growth, a population would normally reproduce at a rate proportional to its size, which means dp dt equals kp, the rate of change of the population is equal to k, the growth rate, times p, the population. When t is 0, which is the initial population, should be equal to c times e to the k times 0, and that's e to the 0, that's 1. So that is equal to c. Usually we call this c p naught. So p of t is usually written as p naught, or you can call it p0 times e to the kt, where p naught is the initial population, and this k is the rate of growth. Now let's look at this word problem. Between 2006 and 2016, the number of applications for patent N grew by about 4.8% per year. That is, the derivative of N of t equals 0.0848 N of d. Okay, let's look at part A. Find the function that satisfies this equation and assumes that when t equals 0 corresponds to 2006, and when approximately this many patent applications were received. This is a pretty typical uninhibited growth situation because the derivative of this function is equal to a certain number, you can call it k, times the function itself. So from here we should know n of t should be equal to a certain number, we call it N naught times e to the kt, where k is the rate of growth. We already know that is 4.8% or 0.048. So I'm going to replace this k with 0.048. Okay, now what is the initial amount? The initial population? That will be this value, right? When t is equal to 0, the initial amount is 446,000, this number, times e to the 0.048 t. That will be the equation of this function n. Now let's look at the B part. Estimate the number of patent applications in 2022. Okay, so knowing the function n is equal to 446,000 e to the 0.048 t, well, we just have to find for 2022, what is our t? So that is 2022 minus the initial year is 2006. So that will give us 16. All right, so that means t is 16. So B is basically asking us to find what is n of 16. Just plug that into the calculator. Times 16. And this number round to the nearest whole number is 961,331. Now let's look at part C. Estimate the rate of change in the number of patent applications in 2022. We know the rate of change is related to the derivative of the function, right? So C, basically we need to find what is the derivative of n. We already know it from the problem, that's 0.048, nt, which is 446,000 e times 0.048 t. All right. So we want to know, the derivative of n of 16. Okay, so that is equal to, just plug in 16 there into the function, whatever that is in the calculator. I'm going to put that into the calculator. Wait, we already calculated this part. This part is this value, right? So you can't just do 0.048 times 961,331. You can't do that. And also round it to the nearest whole number, which is 46,144 applicants per year. So at the year of 2022, we expect the growth rate or rate of change of the applicants to be for 46,144 applicants per year.